So this is something I've designed and built to kind of solve a problem which seems to be cropping up quite a lot recently. The problem being Sepura Tetra terminals that are locked on a master reset pin or puck. The mechanism that makes this happen is somebody applies a pin number to the radio, and then somewhere down the line somebody else ends up with the radio and they don't know the pin, so they just guess it, and once you enter the pin incorrectly 3 times, the radio will drop onto a puck code, and you have to enter the puck code before you can do anything with the radio. There's actually new firmware out, I can't remember, it's version 10 point something, which actually prevents you from reading from the radio or writing to the radio. Like Sepura client won't actually sort of do anything with the radio until you've entered the puck. So it's quite a problem, it's bricking quite a lot of radios. Once one of these is stuck on a puck, there's nothing a home gamer can do as such to solve the problem, other than sending it to Sepura. And I think we know what Sepura will say if you tell them that you've got a Moody radio off of eBay and, you know, it's stuck on a puck code. Anyway, so what I've done is I've modified a programming cable. The other half of the cable still exists, but I've put a connector on the back of it to make it a little bit easier to interface with. So what I can do is just plug this into the back of my box here. Okay, so what I do is I just plug the programming lead into the bottom of the radio, and what you can see up here, the device is aware of the date and time. It's got a real-time clock on board, and here it says next puck and then the puck that it's going to try. This is obviously programmable. I can enter whatever puck I like for it to begin with. I could make it do ranges and all sorts of stuff, but a day or so ago I started it off at 1 and then all the zeros, and it's progressed up to this point and I've stopped it. So the next thing is just a mains power supply button. I can switch the mains supply on and off for the box, and then a start stop button. So if I press and hold the start button, I get a little line comes up here to tell me that it's running, if you like, and what it's doing here is it's sending the pin number, and then it waits for a response. If the response is that the pin number failed, then it increments the pin number, as you can see here, and sends that to the radio. So it sends a pin, radio responds, fail, sends another pin, waits for a response, so on and so forth. Probably one of the only other special things about this is the fact that at any time, say the radio battery goes flat, we can simulate that by just taking the battery off the bottom. What happens is it knows that the last pin that it sent was this ending with 700, and that it got no response. Very simple. It'll just sit there, and what it's doing now is trying this pin number over and over and over and over again until it can re-establish communications. So if I just put the battery on the back of the radio, and there we go, and we're off again. All totally automated, doesn't require any intervention. And I'll show you some of the other bits and bobs that are inside the case as well. These pin numbers are being logged to an SD card, so that if the whole thing went up in smoke, at least I've got a log of the pin numbers that have been tried so far. I can disconnect the programming lead. It has the exact same effect as the radio switching off or the battery going flat. As far as the unit is concerned, it sent a puck code and it didn't get a response. There's a timer times out, and so we get no response on the screen, and it just halts. It doesn't increment the pin number anymore. Dead simple. Plug the lead back in, and once it's got a response to that put code, it'll try the next pin. If you look at the pin number, it's like one pin number every sort of 4.5–5 seconds, thereabouts. Why so slow? It's going to take a long time to, increment through a large amount of put codes. Well, this is running entirely in closed loop, where it sends the put code, and as soon as it gets a response from the radio, it sends another put code. So there is no delay built into my device. This could run millions of times a second, no problem whatsoever. The delay is built into the radio. The radio gets the AT command, and then it takes some time for it to respond. So the delay is sort of built into the radio, it's a function of the radio. Okay, so I'll do a cutscene here and I'll show you inside the box. So if I take the lid off here, obviously normally that would be screwed on from the bottom, but just for demonstration purposes I've took the screws off in advance. Okay, so this is everything inside. Mains power comes in through a filtered IEC socket onto a little meanwhile switch mode power supply. That directly charges up this small lead acid battery, and the whole thing just runs on the lead acid battery. So I can remove mains power and it'll run on this battery for many days. There's not much current draw in here at all. So this is the front panel switch to turn the mains power off. This is the start-stop switch. I haven't chosen these big shiny Vandal resist jobbies for any reason other than I already had them. We've got the main ribbon here coming from the board to the front panel LCD display. Down here is the microcontroller, that's what's doing all the business. I'm using an off-the-shelf Arduino Uno shield for the real-time clock and the SD card slot. I've got a few development boards like this kicking around. It was just convenient to do it this way. They're cheap as chips to get them from eBay, so it's really not worth my time for a prototype to try and knock all this up myself. It's far cheaper just to buy one off the shelf. For the real-time clock there's a little button cell battery here, so if all the power here is removed, the real-time clock continues to run. Back here is a 5-volt regulator that powers everything that's on this board and the microcontroller and the LCD. There's an 8-volt linear regulator here, and I've just lifted that above 0 volts a little bit with a little board mount trim pot, and the idea of that is to get a 10.4 volt reference that's fed into an operational amplifier which feeds the base of an NPN transistor, and that NPN transistor is feeding this port here, which is the connected to the bottom of the radio. So this keeps the radio battery charged. The charging circuitry is actually inside the radio, and all you need to do is feed it a voltage. The spec says, I believe it's something like 10.2 to 10.8 volts, something like that. I can't remember exactly. I've got a programming port down here, so I can just plug a lead into this and reprogram the microcontroller, and that's about it really.